So we have another problem to take a look at as a result of the time constraint, the time crisis that we faced. So we have on our screen a problem, and it says that Nkwanta is a small town in the eastern region of Ghana. It has been estimated that the population of this town is about 2,000 people. And the population is increasing at a rate of 15% every 6 months. They are required to write a computer solution to determine the number of years that would take the population to exceed 2 million for the village to become a city. So, from the question, you can see that for a particular village to become a city, there is more or less a clause that village should exceed 2 million people, right? The population should exceed 2 million people. I want to say this. If I'm going to be 21 next week, then it will take me a whole week before I'll be more than 21. I don't know if that is clear, but anyways, that's a passing comment. So let's start and see how we are supposed to start something like this. From here, we are not supposed to take any input from anyone. So for those thinking of taking an input, forget. Over here, we've been given some items, and then we know something about the current population of the town. So you can set population as a variable. Should be small. Population is equal to 2,000. And then we had another item too. The rate is 15%. So rates, you can decide not to write the rate, it doesn't matter. I'm just listing the items that they give. Please, the 15%, don't try writing something like this. Please, don't try writing something like this. Convert it to decimal and write it. That makes you safe, right? All right. I'm sure some of you know the reason, so I'm not really going to explain that. And then the time. Right now, we want to measure the number of years to take us from 2000 to get to the, what do you call it? The time that it will reach 2 million. So we need to be very careful when we are writing the time. The time should be set to 0. We would need something that checks the loop, right? If you want to use a for loop, you can. If you want to use whichever loop, you can. Now, my loop should have a control variable. The control variable is going to be my population because I want to stop when the population is equal to 2 million. Now I've written this 1, 2, 3, all right? So what happens is, before we enter the loop, the population was already 2,000. So I want the loop to stop. You know, a loop will only stop when its condition is false. So when we enter the loop, we are going to do some things that's going to cause the value of the population to increase. When the value of population increases inside the loop, they will definitely come back to the top here to check, is it within the range? The only time the loop is not going to be in range over here, like the condition, is when the value of population is more than 2,000 or equal to 2,000. That actually solves the thing. If you decide to put an equal sign here, what will happen is when the value is even 2,000, it is going to run again to now try to increase the value of years. And that's not what you want. You want the loop to stop at its first count. The first item or the first number of years that will cause the loop to now be false is the item that we are talking about. That's why I said that if I'm going to be 21 next week, then it will take me just 1 week before I become more than 21. But after next week, I become 21. The subsequent number of days that follow, they don't really contribute so much to my age, but it's after that particular 1 week that I'll start changing from being 21. Basically, that's my layman way of explaining this. So the first thing that happens is anytime we are inside here, we are supposed to increase the value of population the moment the number of years has increased to years plus 0.5. Years plus 0.5 is our own way of saying uh, there has been 6 months come a new set of months which are in a number of you understand what I'm saying? 6 months have gone and come, so we have to increase the number of years by 0.5. And now what happens here too is when years increase, then the population will have to increase. So population has to be equal to the old population, which would have been population. In mathematics, we would have said something like this: population plus, it increases by 0.15, so population plus 0.15 population. That's what happens. But we are very smart to the point that we will write it this way: population 1.15 star population. If you don't understand this, I don't know what you want to understand again. That's the end of the loop. And then I'm sure we are ended, but like we are done. So for the first time, the number of years is going to be increasing by 0.5, and then population will increase. Population increases. Let me see if I can. Nah, I won't do it. It's okay. So basically, when we are entering, because the value of population is 2000, it is less than this range, making this particular assertion true. Then we'll increase the number of years by 6 months. And then when we do, we'll increase population. So population goes to a particular point. I didn't want to sort of do a demonstration, but anyways, I'll have to do that. Where are we? Where are we? Where are we? Hold on. Since you don't want to calculate yourself, then I can't find my calculator. So for the first time, we'll have 2,000 times 1.15, and that gives us 2,300. So for the first time the loop runs, we'll increase year, all right. So when we increase year is going to be 0.5, which is the 6 months. And then with that, we are going to have population being 2,300. And then because 2,300 is still within this range, the loop is going to run again. And they will add 0.5 to years, and we are going to have 1.0. And that's going to be 2,300 times 1.15. That gives us 2,645. And then because it is still within the range, it continues. You understand? Me, I'm not going to do it. Go and do it. The time that the number of years like changes, anytime it changes, population changes, we'll get to a point where population changes to either be equal to 2 million or it will be more than 2 million. That's what to make this one false. By that time, we have already set the number of years that we need, and that's what we are going to print down here. Print years, and then we are done. Okay, whatever is down here is for illustration. All right, so that's that stuff.